Chapter 3, Section 1, we're going to do reference angle. I think we've done these quite a few times before, but we're going to add a little bit of a twist when it comes to finding reference angles that aren't quite 30, 45, or 60. We're also going to do it where we have to do inverse sine, inverse cosine, inverse tangent to figure out the reference angle. So that's a little bit of a twist here. But remember that the reference angle is any drawn in standard position. It is positive acute angle between the terminal side and the x-axis. So here 30 degrees is a reference angle because here's the x-axis and that angle right there is acute. If I were to graph 135, the reference angle is right there, 45 degrees, and I got that by taking 180 minus the 135. How did I get the 180? Well, that's the measurement of the entire straight line right here. Now, if I go 240 degrees, that puts me in the third quadrant. Right here is the reference angle. So if I take out that straight line of 180, that should give me my reference angle of 60 degrees. 330, I'm going to go almost full circle, but not quite. Okay, here's the x-axis. Right here's my reference angle. What I'm going to do is I'm going to take 360 minus that 330, and that's going to leave me with my reference angle in there of 30 degrees. Denote that you see this symbol, they're talking about the reference angle. I often use this with a little prime on it to talk about the reference angle. Okay, here we go. Make sure you go with the x-axis. Here's some rules of what I just kind of did. You know, you can kind of read through those. It is its own in the first quadrant. You subtract it from 180 in the second quadrant. You're going to subtract the 180 from the angle in the third. And then you're going to take away from 360 in the fourth. I kind of like to graph the angle and get a kind of a visual first, though. Don't forget that you have all students take calc, just like we talked before. All meaning that sine, cosine, and tangent are all positive in quadrant 1. In quadrant 2, only sine is positive, the other two are negative. In quadrant 3, tangent's positive, the other two are negative. And then in quadrant 4, cosine's positive and the other ones are negative. So don't forget about your location. So to evaluate certain degrees in cosine of 300, I'm going to find and graph 300, and that puts me about right there. Now, that angle right here is my reference angle. That's going to be 30 degrees. So if I take the cosine of 30 degrees, and I would get that from taking a special right triangle, so it wouldn't be a bad idea to put down your 30, 60 right triangles, just so you have them for reference. It might not hurt also to do the same thing for your 45 right triangle as well. But cosine of 30 adjacent over hypotenuse would be the square root of 3 over 3. But because of all students take calc in the fourth quadrant, cosine's positive. Hey, guess what? It stays positive. So the cosine of 300, the square root of 3 over 3. Sorry, not 3, 2. Deuce. Okay, 135. Pull the reference angle. Here's 135 as a graph. The reference angle is right there. It's 45 degrees. So I'll do the sine of 45 degrees, which is the square root of 2 over 2. Okay, all students, sine's positive, so it stays the square root of 2 over 2, and it stays positive because it's in the third quadrant. 210, I guess I switched colors right here, but I need that reference angle in there, so I'm going to take 180 away from 210, and it works out to be 30. The sine would be 1/2. So if I took the sine of 30, not 130, it's 1/2. But because 210 lies in the quadrant where only tangent's positive, I guess I took the wrong one. I took sine. That's my bad. I got all focused on sine. I should be taking the tangent of 30. Sorry. So tangent, the square root of 3 over 1. And it stays positive because tangent's positive in that quadrant. Cosecant. So you're going to find the reference angle. You go 120. Reference angle there would be 60. Cosecant is 1 over sine. So I'm going to find the sine of 60 degrees. And what I'm going to do is I'm going to flip that around. But the sine of 60 is going to be the square root of 3 over 2. So cosecant is going to be 2 over the square root of 3. Or if I rationalize that a little bit, I'm going to multiply by the square root of 3 and get 2 square roots of 3 over 3. Now all students take calc. I'm in the second quadrant where sine is positive, so cosecant's also going to be positive. Okay, so check two things, the reference angle and where it lands to make sure you have the appropriate sign. So with that being said, I'm going to go sine of theta is equal to this negative number, whatever. I am going to have to find out what that theta is. So I'm going to take the inverse sine of both sides. And when I take the inverse sine, that's essentially going to give me that theta. Okay. Which is a negative angle, but ignore the negative. And if I round, it's about 32 degrees. My reference angle is 34 degrees. Where do I put that 34 degrees? Well, it says that the angle ends up in quadrant number 3. So when I graph this guy, I got this angle here that's 34 degrees is the reference angle, but the actual angle I'm looking for is this entire thing. So I'm going to take this 180 plus the 34, and the angle that puts me in the second quadrant is actually going to be 214. Now, how did I get the 214? Because I had to go the halfway mark, 180, plus the additional 34. Very similar in the second one, except for to find theta, I will use the inverse tangent operation. So I'll take the inverse tangent to that formula. Be careful. This answer is not the angle. It is just the reference angle. So I'll use theta is equal to approximately 40.5 degrees. So when I make a sketch, I'm looking for quadrant 2. So I'm going to go and I'm going to put this 40.5 right there in quadrant number 2. So the actual angle that I'm going to use is going to be 180 minus that 40.5. So 139.5 degrees. Again, it's because I'm in the second quadrant. So when it comes to secant, well, hey, guess what? Secant is 1 over cosine. So with a little bit of algebra, I can get the cosine of theta is equal to 1 over 3.7651. And then I'll use the inverse cosine. So the inverse cosine of 1 divided by 3.7651. Okay, again, I'm getting the reference angle, so that means theta is 74.597. So if you wanted to go 74.6, that'd be fine. What quadrants would this fall in? Well, let's think about this. I go back up to my original, decimal 3.7, and that is actually a positive number. Well, if that's a positive number, that means that I have all students take calc. It's got to be in quadrant 1 or quadrant 4, because if it is secant, cosine's positive there, so is secant. So I'm going to put that reference angle in the first quadrant, which means that 74.9 is flat out the angle. So there's one possibility. My second possibility is 74.9 being right there. So I'm going to take the full circle minus the 74.9. So 360 minus the 74.9. And my other possible angle is going to be the 285.1. Now, these two work because, again, location, location, location. If I've got a positive number, cosine's going to be positive in first and second. And that is reference angles and how you use all students take calc.